Hey all, today we're going to start our unit on right triangles. We're going to talk about special right triangles. So there's two types of right triangles that we call special right triangles. And we're going to use some of our knowledge of radical operations and even similar triangles to assist in using these triangles. So start by adding this to your flipbook where you see the 45, 45, 90 triangle. That's our first special right triangle. We call it a 45, 45, 90 degree right triangle because it has not one, but two 45-degree angles. And then, of course, it has a right angle. So when we have a right triangle that has two 45-degree angles, we know a couple things about it. We know that the two legs are both going to be the same size. And the hypotenuse is going to have a factor of the square root of 2 for its length. So this is our special right triangle, and this is what we call a reference triangle. So whenever we have any 45, 45, 90 triangle, we can use this reference triangle to help us find lengths of sides. So let's do an example. Over here, I have a 45, 45, 90 right triangle. And I can see that one leg is 3 root 2, the other leg is y, and the hypotenuse is x. Remember that the hypotenuse is always across from the 90-degree angle. So I'm going to redraw my reference triangle in the same orientation that this triangle is in. Just like that. My two legs I'm going to label 1, and my hypotenuse I'm going to label root 2. Since they have all the same angles, we know that these are similar triangles by the angle-angle theorem, and so we can write the ratio of their corresponding sides. So if you draw this reference triangle in the same orientation as the triangle you're looking at, I can just match the sides up. So 3 root 2 goes with 1, x goes with root 2, and y goes with 1. So I can write these three ratios. And then we're going to continue on the next page, and we're going to solve for x and y. So there's my three ratios. I'm going to write two proportions, one using x and root 2, and this one over here that doesn't have a variable, and then one using y over 1, and this one. So I get two proportions, and now I just have to solve a proportion like we have been for the last few weeks. So the one on the right, solve for y, is kind of easy. Both of them are divided by 1, so we could just get rid of the divided by 1, and we know that y is equal to 3 root 2. For this one, we'll cross multiply, so 1 times x and 3 root 2 times root 2. We know from our last lesson that we can multiply these two root 2's to get root 4, and that root 4 becomes 2 because 4 is a perfect square. So we can find out that x is 6. So we can do the same thing for any right triangle that has 45-degree angles. If I know that one of these angles is 45, I know the other one must be 45. That's why they're not both labeled. So I'm going to draw my reference triangle. And then I'm going to write the ratios. So my 5 root 2 goes with the root 2. Both my x and y go with 1, so I get these three fractions. Then I'll write two proportions, one so I can solve for x and one so I can solve for y. And then because x and y are both divided by 1, we can just get rid of the divided by 1, and we don't really have to do much solving. We'll find out that x and y are both equal to 5 root 2 over 2. And you can leave it just like that. It looks maybe like it's not simplified, but that's good enough. So I want you to go ahead here, and I want you to find the value of m, and I want you to find the value of n. So I'm going to draw my reference triangle and write my three fractions. Then I'm going to set up two proportions, one for m and one for n. N seems to be the simpler one to find. N and 9 are both divided by 1, so we know that N is equal to 9. Here I'm going to cross multiply 1 times M and 9 times root 2. And so we can leave it just like this. M is equal to 9 root 2. So our second special right triangle is the 30, 60, 90 right triangle. It has a right angle, and then it has a 60-degree angle and a 30-degree angle. The hypotenuse we label with a 2. The side across from the 30-degree angle we label with a 1. And the side across from the 60-degree angle we label with the square root of 3. And so this is our 30, 60, 90 reference triangle. So you noticed that in the 45, 45, 90s, they only labeled one angle. Here they do the same thing. So if one angle is 60, that means the other angle is 30. Or if one angle is 30, the other angle is 60. And we draw a reference triangle in the same orientation. It's really, really important that you label the 30 and the 60-degree angles so that you can label the sides correctly. So again, the 30-degree angle is across from the side that we label 1. The 60-degree angle is across from the side that we label root 3. And then we can write our ratios like we did with the 45, 45, 90. And so we're going to solve this one on the next page. I write my two proportions, one for x and one for y. So here, I don't need to cross multiply because y is divided by 1, so that's just y. And then I can simplify because I can cancel out these two root 3's. And I'll get y to be 5. For x, I'm going to cross multiply and get x times root 3 and 2 times 5 root 3. And from our last lesson, we know that we can multiply the 2 and the 5 on this right side and get 10. And then I'll divide both sides by root 3. These root 3's cancel, and I get x to be 10. So it's the same process as a 45, 45, 90, with the exception that our reference triangle has different lengths for the sides because of the different angle measures. So do one more together. Here I have my 30-degree angle. And so that means this angle over here is 60. So I'm going to draw my reference triangle in the same orientation. Side across from 30 is 1. Side across from 60 is root 3. Hypotenuse is 2. And then I can write my fractions. Set up two proportions, one for u, one for v. V is nice and easy because we can just get rid of the divided by 1 and say that v is equal to 9 over 2 or 4.5. Here I'll cross multiply 2 times u, 3 times, or root 3 times 9. Then divide by 2. And you can leave your answer like this, even though it looks kind of complicated, or you can tell me it's 4.5 root 3. So I want you to pause here, and I want you to give this one a shot. I'm going to draw my reference triangle and write my fractions or my ratios, and then set up two proportions, one for n, one for m. N's nice and neat. N divided by 1 is n, and 2 divided by 2 is 1, so n is equal to 1. And here I'll cross multiply 2 times m and 2 times root 3. Then divide by 2. These 2's cancel because 2 divided by 2 is 1, and so m is equal to root 3. So when you're done, I'd like you to show me your notes, show me what you did. If you have questions, please, please, please ask.